Hello, my name is Dr. Sheryl Genco. I'm the Vice President of Advanced Technology Group in Ericsson, and I'm an Executive Committee member with the National Spectrum Consortium. I'm absolutely delighted today to be speaking with Kate, who's an electrical engineering PhD student with a concentration in applied electromagnetics at Georgia Institute of Technology. Kate is one of the winners of NSC's second annual Women in Spectrum Scholarship. This program promotes academic accomplishments of female students studying electrical engineering at U.S. ABET-accredited universities. We designed this program to help develop the pipeline of talented engineers working on issues related to spectrum and communications, and we're absolutely thrilled to support this year's winners in that work. So Kaitlyn, welcome, and thank you for applying and for studying electrical engineering. Could you just tell us all a little bit about how you became interested in studying EE?
Yeah. So I first got introduced to engineering through one of my parents who's a mechanical engineering as a professional, and she does more like MEP building construction consulting. Um, so like going throughout school, I was always interested in math and just having that like engineering introduction through her. So when it came time to, I guess, pick a major for my undergrad, I knew I was going to do engineering just because all my experience through high school and middle school. And yeah, I was kind of torn between what kind of engineering to do. So I ended up doing one of those like pre-college programs at
Mhm,
my undergrad, Illinois Tech.
mhm,
But I did it for biomedical engineering.
mhm.
So I actually started out as a BME major, but then I realized I wasn't too interested in biology, but there was a lot of overlap between like BME and electrical engineering since I was still like really interested on what they were doing on like biotechnology on that BME side. So I ended up switching majors to electrical engineering and then finding out about like wireless communications and spectrum through one of my internships. So
That's
switched
great.
paths a little bit. Yeah.
Yeah, I think that's what's great about internships in general is that you can explore these things. I know when I was a student a million years ago, I definitely had a very similar experience. I think I bounced in and out of every engineering major, including
Yeah.
bioengineering, biomedical, and ended up right here in the same place you are right now. So I can certainly understand that. Now you mentioned an internship. Are you doing research now as part of your PhD or your internship? Could you tell us a little bit about the work you've been involved in?
Yeah. So my first introduction to spectrum was through my internship with the Naval Surface Warfare Center in Crane, Indiana. And there I worked on a little bit of like spectrum sensing technology and also creating like low size, weight, and power alternatives to like antenna test systems.
Mm,
So like when they bring it on board the huge like naval surface ships, they don't have to carry these like giant equipment up all the tiny stairways. Um, so through there, I my mentors and the other people on my team, they were all PhD or they all had their PhDs. So it kind of inspired me. It was like, wow, I really like how they think and how they could, just come up with a solution so fast. And I kind of wanted that for myself. So I decided to continue on with school and join a PhD program at Georgia Tech. So right now, I just finished up my first year. So I've been working on some more spectrum sensing stuff. I've been trying to create a reconfigurable antenna array using RFID tags as a solution for small scale fading mitigation. Um, just because like when you think about all the signal traffic that we have in the spectrum and all that congestion and the continued growth of all the wireless devices, the current static frequency allocation scheme is
mm,
going to have a hard time managing that all. But with more dynamic schemes such as like cognitive radio or the National Radio Dynamic Zone and digital spectrum twins, they all need to have a very reliable spectrum monitoring source. Um, but with all that traffic, it could create like interferences in the multipath. So with this reconfigurable antenna array, it's switching through different radiation paths to try to make sure fading nulls don't happen.
Well, that's super cool, and certainly I think everybody that sees this video is going to really, attach itself to your research and what you've been doing, because it's certainly one of the biggest problems we're all trying to face.
Yeah.
Absolutely. And I did notice how you do love it. I could tell already because I could see you smiling when you were talking about your internship and your research, and I think that's what we're looking for, is that sort of excitement about engineering across the board. So I know you've just started or concluded your first year in graduate school, but what are your career goals, or how do you have any plans to continue to stay involved in spectrum and wireless comms after graduation?
Yeah, I for sure will be staying within this field. I enjoy it a lot, so I don't see myself switching paths. Um, as of right now, I'm kind of thinking of going into more industry research. However, like I haven't ruled out academia. I guess haven't had a lot of experience when it comes to like teaching. So I hope to gain more of that throughout my PhD program to see where I'll end up by the time I graduate.
Fantastic. That's wonderful. Well, we're really happy that you applied for this scholarship, and we hope that at Milcom, we can help, introduce you to other engineers as well. That'll be, help you along on your career. So in general, why do you think more young women aren't studying engineering in general, or electrical engineering specifically? And what might we do? Do you have any suggestions for getting more women into the field?
Yeah, I actually saw like a small study that was done by the Girls Who Code program, and
Mhm.
they had like statistics on um, how in middle school, like the girls' confidence in pursuing STEM drops significantly. So I
Mhm.
think that plays a large role and is like a good like target age for outreach programs. Um, because just based off of my own personal experience, like I've, had a parent who's an engineer, and I was able to, participate in like science fairs in middle school and
Mhm.
join the science club in high school. So that all like definitely put me on the path to where I am today. So being able to provide more opportunities for younger girls to get that same experience, I think will help a lot. And then also, I think having like mentorship and like role models and also a good support system is very important.
Well, that's very true. I mean, I've seen some of those statistics about all students with regards to math in middle school. It seems to be a very pivotal time for all students to get on the love of math, as I say.
Yeah.
So, but I would love to see the Girls Who Code study. Maybe you could email it to me. So,
Yes.
we'll be seeing you at IEEE Milcom. I can't wait. And again, I want to thank you for your time today to talk with us a little bit about spectrum and electrical engineering, and good luck in your electromagnetics studies.